If Rhino is starting to feel slow, if your models keep breaking halfway through your work, or if your Booleans fail for no clear reason, the issue usually isn't Rhino itself. It's a series of small mistakes that almost every beginner keeps making without even noticing. And the dangerous part is this. At the beginning, they seem completely harmless, but as your project grows, they quietly build up and eventually turn into serious problems that can ruin your whole workflow. Hey, I'm Hossein, and welcome to my YouTube channel. In this video, we're going to talk about 15 very common mistakes in Rhino mistakes that almost everyone makes, especially when they're just starting out, usually without even realizing it. But this isn't just going to be a simple list of names. We're going to break down each mistake properly, what kind of problems it creates in your model, why it happens in the first place, and how it can slowly turn a project that looks fine at the beginning into something messy, unstable, or even completely out of control halfway through. And most importantly, for each one, I'll show you a simple, practical fix. So from day one, you can build the right habits and avoid falling into these patterns. Because the goal of this video isn't just to learn Rhino, it's to learn how to model clean, precise, and professional work without getting stuck in the middle of your projects later on. 1. Everything on a single layer. One of the very first and probably most common mistakes in Rhino is modeling an entire project on a single layer. At the beginning, it doesn't even feel like a problem. Your projects are small, things are simple, and it seems like there's no real need for any structure or organization. But the problem starts when the model grows. As the amount of geometry increases, everything begins to mix together and you slowly lose control over your project. At that point, even the simplest tasks become frustrating. You can't isolate just one part of the model easily, you can't apply changes to a specific section, and every small selection forces you to deal with the entire scene. Instead of a controlled model, you end up with a messy space where finding and managing elements becomes time-consuming and exhausting. The solution isn't complicated. From the very beginning, you need a simple and logical layer structure. For example, separating things like reference curves, surfaces, and details. It might feel unnecessary at first, but it's exactly this kind of basic structure that keeps your project under control and makes everything significantly easier as it grows. 2. No version control working on a single file. Another very dangerous mistake in Rhino is working with just one file and constantly overwriting it. At first, it feels completely normal, even convenient. You think you always have the latest version and everything is under control. But the problem shows up the moment you make a wrong design decision or you change direction mid-project and suddenly realize there's no easy way to go back, or it takes so much time that it's not even worth it. The truth is, Rhino is not just a modeling tool, it's also a tool for exploring ideas. You're supposed to experiment, try different directions, and iterate freely without being afraid of breaking everything. But when you rely on a single file, you lose that freedom. Every change becomes a risk. Even Control-Z can't replace proper version control because it's limited to recent actions and can't bring back older states of your project. The solution is simple. From the very beginning, build a basic versioning system for yourself. Something like VO1, VO2, VO3, and so on. It might look trivial, but in practice, it's one of the most important habits for keeping your project under control. It gives you a safe point to return to and the freedom to design without fear. 3. Scaling without numbers. Another very common mistake in Rhino is scaling things visually without using real measurements or exact values. At the moment, it feels fast and convenient. You just drag, eyeball it, and adjust the model until it looks right. But the problem is that architectural design and 3D modeling are not based on visual intuition alone. They are based on precision and measurable data. When you rely on guessing, even small inaccuracies start to appear. Maybe it's just a few millimeters or a couple of centimeters. Visually, it's almost impossible to notice. But later on, when you get into details, connections, fittings, or coordination between elements, that's when everything starts to fall apart. Parts don't align properly, proportions feel off, and in many cases, you end up reworking entire sections of the model just to fix issues that started from a small scaling mistake. The solution is simple. Always use numeric scaling or real-world references. Either input exact dimensions or base your scale on a known reference object. In Rhino, accuracy isn't an option, it's the foundation of professional modeling. When you work precisely from the start, not only does your output become cleaner, but most of these problems never even appear in the first place. 4. Deleting construction curves. Another very common mistake in Rhino is deleting your construction curves once the model starts to look clean and finalized. At first, it feels logical. You think these lines are just extra clutter, so removing them makes the file cleaner and easier to manage. But the issue is that these curves are not just extra lines. They are actually part of the logic behind your model. They show how the form was generated and what process led to the final shape. When you delete them, nothing seems to change at first. But later, especially when you need to revise or adjust parts of the model, you suddenly realize you no longer have any guide for rebuilding or understanding that form. In other words, your model turns into a frozen object. It looks finished, but the construction logic behind it is completely gone, making edits difficult or sometimes even impossible without starting over. The solution is simple. Don't delete them, manage them. Instead of removing construction curves, either hide them or move them to a separate layer. This way, your model stays visually clean, but you still preserve the logic behind the design. In reality, these curves are like the skeleton of your work. They might not always be visible, but they are what hold the entire structure together. 5. Too many control points, over-controlling the geometry. One of the most common mistakes in Rhino is thinking that more control points automatically mean more control over the form. At first, it sounds reasonable. The idea is simple. The more points you have, the more precisely you can shape the surface. But in reality, it works the opposite way. When the number of control points increases too much, the surface starts becoming unstable. The form loses predictability, and even small adjustments can distort the entire geometry. Instead of gaining control, you actually lose it. Surfaces start to feel wavy, the quality drops, and even simple edits become difficult and unpredictable. The solution is to keep your geometry as simple as possible. If you notice that control points are getting out of hand, you should restructure the surface using tools like Rebuild to bring it back to a clean and logical form. In Rhino, more complexity doesn't mean better quality. In many cases, simplicity is what gives you real control over the form. 6. Boolean operations that keep failing. One of the most frustrating things in Rhino is when you run a Boolean operation and it fails without any clear reason. Most users immediately assume it's a bug or a problem with the command itself. But in reality, Boolean almost never fails because of the tool. It fails because of the model. When surfaces don't properly intersect, when edges are open, or when the geometry isn't clean and watertight, Rhino simply can't understand how the shapes are supposed to combine or subtract from each other. So the operation breaks even if everything looks perfectly fine at first glance. This is actually one of those moments where Rhino is telling you something very important. Your geometry is not clean or complete. The problem is that most people ignore this signal. The solution is to always do a quick check before running any Boolean. Make sure all objects are properly joined, check for any naked edges or open boundaries, and clean up the geometry if needed. When these conditions are satisfied, Boolean operations almost always work smoothly. In other words, Boolean isn't broken, it just expects your model to be ready and well prepared. 7. Naked edges. Another issue, or more accurately, a hidden problem that often goes unnoticed in Rhino is the presence of naked edges in your model. The important thing is that your model can look completely solid and closed at first glance. Visually, everything seems fine and there are no obvious signs of a problem. But in reality, some surfaces are not properly connected, or their edges don't meet correctly. This creates open boundaries in your geometry, what Rhino calls naked edges. At the moment, it might not seem like a big deal, but later in the process, it can cause serious issues. In rendering, it can lead to light leaks or material glitches. In analysis or fabrication, it can make the model unreliable or even unusable. In some cases, it can invalidate entire parts of a project. The solution is simple. Always check your model. Rhino provides a basic but powerful tool called Show Edges that lets you clearly detect these open edges. It might look like a simple check, but in practice, it's one of the most important health checks for your geometry. If you use it consistently during your workflow, many of the problems that usually appear at the end of a project will never even happen in the first place. If you've enjoyed the video so far, I'd really appreciate your support. Please like the video and subscribe to the channel. It really helps me keep creating content like this. If you want to go a step further, you can support the channel through Super Thanks, and I'd genuinely love to hear your thoughts. If you have any feedback, ideas, or anything I didn't cover, feel free to share it in the comments. 8. Working without Osnap. One of the most dangerous but at the same time deceptively simple mistakes in Rhino is modeling without Osnap enabled. At first, it might feel like turning it off gives you more speed and freedom. You're no longer forced to snap to exact points, and it seems easier to draw lines and shapes quickly. But the problem is that nothing is actually precise anymore. You think 2 points are aligned, when in reality there might be a small gap between them, even just a few millimeters. These errors are invisible in the beginning. The model still looks correct, so everything feels fine. But later, when you start doing Booleans, joining surfaces, or even rendering, the problems suddenly appear. In reality, Osnap is what gives your modeling true accuracy. Without it, everything becomes approximation and guesswork. The solution is simple. Build the habit of always keeping essential Osnaps on, like end, mid, sen, and int, unless you're intentionally working in a freeform sketching mode. Otherwise, working in Rhino without Osnap is basically like modeling blind, and in precision work, that quickly turns into hidden errors that are very hard to trace later. 9. Modeling without any reference. One of the fundamental mistakes in Rhino is starting a model without any real-world reference or guide. At the beginning, this approach might feel natural. You think you can simply design everything in your head and gradually shape the form as you go. But the problem is that the human mind is not precise. Even when the idea is clear, without a real reference, proportions can easily drift out of control. As a result, the model might look correct from your perspective, but once you compare it to reality, you realize the scale is off, the proportions feel unnatural, or the form simply doesn't carry the right sense of balance. This becomes especially critical in architecture, where everything depends on human scale and spatial accuracy. The solution is simple. Always work with a reference. It can be a real photograph, an actual architectural drawing, or even a precise, real-world measurement. When your model is grounded in real data, decision-making becomes easier, and the final output becomes far more reliable and consistent. 10. Ignoring the command line. One of the most overlooked mistakes in Rhino is ignoring or completely underestimating the command line. In reality, this is one of the most important sources of information inside the software. Almost everything that happens in your model, whether a command succeeds or fails, is communicated there. But many users simply run a command and immediately move on without even checking what Rhino is actually telling them. The problem is that when something doesn't work, the reason is almost always written right there in the command line. But because it gets ignored, the same mistake keeps repeating without being understood or fixed. In a way, the command line is a real-time feedback system. It tells you whether you're doing things correctly or not. But if you don't pay attention to it, you're essentially missing half of the most important information in your workflow. The solution is simple. Build the habit of briefly checking the command line after every command. It may seem like a small detail, but in practice, it prevents a lot of repeated errors and unnecessary confusion. 11. Overcomplicating the model too early. One of the most common mistakes is trying to build a fully detailed, final quality model from the very beginning. Instead of working step by step, people often try to include all the details, forms, and complexities right away as if they are jumping directly to the final result. At first, this might even feel more professional, because it seems like you're saving time by skipping intermediate stages. But in practice, it works exactly the opposite way. When a model becomes complex too early, it becomes much harder to control. Even small changes can affect multiple parts of the geometry, and every adjustment becomes risky and time-consuming. Instead of focusing on gradually building the form, you end up stuck in a heavy, fragile model that doesn't want to change. The solution is to always start as simple as possible. Build the overall structure first, and then gradually add layers of detail on top of it. This approach gives you much better control over the model and makes it far easier to make changes without breaking everything. In Rhino, real power doesn't come from complexity, it comes from knowing when and how to introduce it. 12. Turning off history. Another common mistake, especially in early stages, is keeping history turned off, or not taking it seriously at all. In fact, history is one of the most powerful features in Rhino for parametric and editable modeling. When history is enabled, many commands like loft, sweep, or extrude stay linked to their original geometry in an intelligent way. This means that if you change the source curves or inputs, the resulting surfaces update automatically. But when this feature is turned off, every small change turns into manual editing, and that quickly means losing flexibility in your design process. The problem is that many users either disable it out of habit or simply don't understand its role. Later in the project, they end up rebuilding or manually fixing large parts of the model, for even minor adjustments. The solution is simple. Whenever you're working on form-driven or iterative design, keep history turned on. It makes your model more alive, and instead of constantly rebuilding things from scratch, the geometry adapts with your changes. 13. Not using groups and blocks. One of the simple but highly impactful mistakes in Rhino is not grouping or blocking related objects, and instead leaving everything scattered as independent elements. At the beginning, it might not feel like a problem. The model is small, there aren't many elements, and everything is easy to manage manually. But as the project grows, this lack of structure starts to show. Selecting specific parts becomes difficult, moving elements leads to mistakes, and overall control over the model quickly starts to fall apart. Instead of working with an organized system, you end up with a large number of independent objects that have no clear relationship with each other. The solution is to use groups when you simply need objects to move or be selected together temporarily, and to use blocks for repeated elements or important components that will be used multiple times throughout the project. Blocks are especially important in architectural projects because they not only bring structure, but also keep the file lighter and much more manageable. In the end, this simple habit makes your model far more structured and gives you much better control over every part of your work. 14. Not setting units and document properties from the start. One of the most dangerous mistakes at the beginning of a project is starting to model without properly setting units and document properties. At first, it doesn't seem important. The project is still in an early stage, everything feels simple, and there's a sense that things can always be adjusted later. But the problem appears as the model progresses. At some point, you realize the entire project has been built on the wrong scale, and fixing it at that stage becomes extremely difficult, or in some cases almost impossible, especially when detailed geometry has already been added. In reality, if the unit system is not defined correctly from the start, every design decision that follows is already affected by that initial mistake. The solution is simple. Before you start modeling anything, go to File Properties and set your units precisely according to the project requirements. It's also important to check basic settings like tolerance and display options at the same time. This might only take a few seconds, but it can prevent major time-consuming problems later in the process. In Rhino, starting correctly means you're already halfway through the project. 15. Drawing curves without planarity when it's needed. One of the subtle but very important mistakes in Rhino is drawing curves without considering whether they are planar, even when they are supposed to lie on a flat surface. At first, it doesn't really seem like a problem. The curve looks correct visually, and the overall form appears fine, so there's no immediate warning sign. But the issue starts when you try to generate a surface from that curve. If the curve isn't truly planar, Rhino can't interpret it correctly, and the result can be twisted surfaces, inconsistencies, or unexpected geometric errors. This becomes especially critical in architectural work, where many forms need to be clean, precise, and actually buildable. The solution is simple. Whenever you're working on a 2D shape or something that should lie on a flat plane, make sure planar mode is enabled so your curves are properly constrained. This ensures that from the very beginning, your surface logic is correct and you don't run into geometry issues later during surface creation. In reality, this small mistake, if not controlled, can break the entire logic of a form in the later stages of your workflow. If you've paid attention to all 15 of these mistakes, you'll notice something they all have in common. None of them are actually problems with Rhino itself. Rhino is simply doing exactly what you're asking it to do. The real issue usually comes from the way we think about modeling, how we start a project, how we organize it, how carefully we work, and how we interact with geometry. A small mistake at the beginning, like not setting proper units or ignoring layer structure, can slowly grow into a much bigger problem later in the process, to the point where fixing it becomes difficult and time-consuming. But the good news is, all of these mistakes are both preventable and fixable, and more importantly, they're learnable. If you start working differently from now on, more structured, more precise, and more aware, not only will your models improve, but your entire design process will become faster, smoother, and far more professional. In the end, Rhino is not just a tool, it's a way of thinking about how forms are made. If you found this video helpful, I'd really appreciate it if you subscribe to the channel so you don't miss the next videos. Thanks for watching, and I'll see you in the next video. Goodbye.